This video is on Unit 6, Chapter 13 on natural logarithms, Lesson number 2, log applications, growth and decay. In this lesson, we're going to look at exponential growth, exponential decay, and something called compound interest. So we're going to start with exponential growth. Exponential growth occurs when a quantity exponentially increases over time. So these exponential functions, you can think back to parent functions and what those look like. Exponential functions grow quickly for exponential growth. So that's the one that kind of hugged the x-axis and then shot up. So there's a growth going on, an increase in value that happens very quickly with exponential growth. There is a formula. It is a function of time. So with exponential growth and exponential decay, these are functions that occur over a period of time. So f of t is equal to a times 1 plus r raised to the power of t. And to the right here, it explains what each of those letters stands for. So a represents the initial amount or the beginning amount. R represents the growth rate, which is a percent. And then T, of course, is time. So let's look at this first example. Example number 1 says the original value of an investment is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. So let's talk about what this means. So what is A? A is the original or the initial amount. So that would be your 1800. Your R is your rate, which in this instance is 7%. Now, when we're putting this into an equation, we cannot use the 7%. We have to change it to a decimal or a fraction, one or the other. So to change a percent to a decimal, the decimal point is always, on a whole number like 7, is to the right. And we're going to move the decimal 2 places to the left. So 7% is equal to 0.07 as a decimal. And then we've got our time, which eventually we're going to plug in. That's the time of 15 years. So we're going to take our original equation and we're going to put this in. So f of t is equal to 1800 parentheses 1 plus 0.07 to the power of t. So I'm going to do the 1 plus 0.07 and you get 1.07. So f of t is equal to 1800 times 1.07 to the power of t. Now that's your function. It said write an exponential function to model that situation, and that would be your function. Then they want us to find the value of the investment after 15 years. So that time equals 15 years. So we're going to go back to the calculator. We're going to put the 1800 times 1.07 to the 15th power. And we get $4,966.26. So $4,966.26 after 15 years. Let's do one more here for exponential growth. In 2002, there were 972 students enrolled at Oakview High School. Since then, the number of students has increased by 1.5% each year. Write an exponential function to model the situation, then find the number of students enrolled in 2014. So again, y'all, this is growth, and I know it's growth because of the word increase. So let's define our variables. A is the initial amount or the beginning amount, which is 972. R is the rate, which is 1.5% or 0.015 as a decimal. Now T, for your time, you've got to take the 2014 and subtract 2002. So we get a T value of 12. So let's write our function. So F of T is equal to 972 times. We're going to take 1 plus 0.015. No, 0.15. No, 0.015. I'll get it right. So 1.015 to the power of T. And again, you're writing the function, and y'all, we could use this for anything. So the way that function is written, we could estimate how many students are going to be enrolled at Oakview High School in 2021, 2022. Using this function, we can do any number of years. But now we want to specifically do 12. So F of 12 is equal to 972 times 1.015 to the 12th power. So we've got 972 times 1.015 to the 12th power. And we get 1,162. Now that 0.14 is a partial student. We're just going to round to a whole number here, 1,162 students. All right, that brings us to exponential decay. The formula for decay is almost identical to growth. F of T is equal to A times 1 minus R to the power of T. So with decay, we subtract the percentage from 1. And y'all, exponential decay occurs when a quantity exponentially decreases over time. So it decreases. A is still the initial amount. R is still your decay rate. And it's still a percentage. You need to change it to a decimal. And T is still the time. All right, so let's look at example number 3. An investment of $12,000 is losing value at a rate of 4% each year. Write an exponential function to model the situation, then find the value of the investment after 9 years. So same scenario, except for it's losing money, and that lets me know that I need the 1 minus R. So A is 12,000. R is 4%. Move the decimal 2 places to the left, and you get 0.04. And then your T is 9 years. All right, so let's write our function. So F of T equals 12,000. Now, I want to do 1 minus, let me just do the 1 minus the 0.04 to the T. 1 minus should give me 0.96. So there's the 0.96. To the power of T. So there's our function that we could use to figure out what the investment would be worth, however many years we want to go by. But let's specifically find 9. So F of 9 is equal to 12,000 times the 0.96 to the 9th power. So 12,000 times 0.96 to the 9th power. And we get $8,310.41. So after 9 years, the $12,000 has decreased to $8,310.41. Not sure why they left their money in that investment. All right, so let's jump over to compound interest. So compound interest also has a formula. Compound interest occurs when interest is calculated on both the principal amount and the accrued interest thus far. Now, this is a concept that's a little foreign to a lot of students. Basically, what's happening is after a given period of time, the initial amount is going to earn interest. At the end of a certain amount, they recalculate the new interest based on the original amount plus any interest that it has earned up to that point. So again, your formula here is A is equal to P times 1 plus R divided by N raised to the power of N times T. So what do each of these letters stand for? Well, P is the principal amount or the initial. R is still your rate. It's still a percent. Don't forget to move the decimal. N is the number of times it's compounded yearly. The yearly is important. And then T is time. So let's look at example number 5. Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So here's some vocabulary. Quarterly, how many quarters are in a year? How many quarters are in a whole? So for this, it's 4 times per year. So N equals 4 here. The 12,000 is your P, 8% is your R, and then 5 years is your time. Now, we're going to plug all that in. So A equals, the principal is the 12,000 times 1 plus, the rate is 8%, so that's going to be 0.08 or 0.08 divided by N is 4, and all of that's going to be raised to N times T. We're going to go ahead and put the 5 in there. So let's clean this up. Let's go to the calculator and do the inside of the parentheses. 1 plus 0.08 over 4. So the inside is 1.02. And then 4 times 5 is 20. So now we can plug that all into the calculator. 12,000 times 1.02 to the 20th power. And that gives me $17,831.37. So now what that means is Laura's deposited originally $12,000. After 5 years at 8% interest, her $12,000 is now grown to $17,831.31. So if I subtract off that original $12,000, that means her money has earned $5,831.37 in the 5 years. So the amount of interest is $5,831.37. That's kind of the nutshell here. Yes, this is your answer. That's the amount that she's going to have in her account. But if I ask you how much interest did it earn, the $5,831 would be your answer. The vocabulary on these word problems may be what gets to you. So when it says something like compounded monthly, that means n is equal to 12 because there are 12 months in a year. When it says compounded semi-annually, so let me start with annually. Annually, ANNUALLY, means that n is equal to 1 time per year. So semi-annually means that that's going to happen twice in a year. On number 8, compounded bi-monthly means 2 times per month. So bi-monthly, how many times in a year? N would be equal to 24. And then on the last one, the interest is compounded weekly. How many weeks in a year? N equals 52. So the compound interest, again, y'all, is just a formula. You guys can pick out those pieces of information, put those into that formula, and stick that in the calculator. That is not the problem. The vocabulary might be the problem on compound interest. But this is your video for Unit 6, Chapter 13, Lesson number 2 on growth and decay.